Hey guys, welcome to NEET World of day 3. So in this class now we'll see about the relative velocity. So in day 1 and day 2 we covered about graph as well as projectile motion, right? So in day 1 we covered about the graph. In day 2 we covered about the projectile motion. So today is the day 3 of the 100 days challenge. So in this class we will cover relative motion. So in 4th day also we will cover the continuation of the relative motion. Okay, yeah, we will go into the class. Yeah, so relative motion in physics. So we will see about relative position, velocity, acceleration, like, and then velocity of approach, velocity of separation. So velocity of approach and separation, see in this concept now, like two objects are there, A and B, they are approaching each other, okay, or else like separation, A and B are there, they are going away from each other. Like what is the relative velocity with respect to A or with respect to B, we are going to find it. So first we will see what is relative motion. So relative motion refers to a motion of an object as observed from another moving object. Like one object is moving, other object is also moving, like two objects I will consider, two objects are there, object number A and object number B. So both are moving. So if B is moving, okay, I am sitting on A and I am watching B. So I will see what is the velocity of B. I need to find what is the velocity of B. That is the main motive of the relative motion. So relative motion refers to the motion of an object as observed from another moving object. So both are moving objects only, okay. It depends on the observer frame of reference. Like whenever we are calculating relative motion, relative velocity or anything, acceleration, okay, the frame of reference is the important thing, okay, frame of reference is the important thing. So for example, they have given that two trains moving parallel to each other, like we have taken two objects moving in the same line or same line of path, we will say, but in this thing they have said that parallel to each other, no, one is going like this and one is coming in the opposite way, parallel to each other. So suppose in this train a person is sitting, okay, and in this train a person is sitting, okay. So this person is watching this person and they are asking what is the velocity of the person B with respect to A, no, like A is the person watching B and you want to find the velocity of the person B. Then what you will say? Yes, what you will say? So velocity of A with respect to B. If suppose no, velocity of B, like B is the person watching A, like B person need to calculate the velocity of A. What you will say? Velocity of B with respect to A, right? That's what the relative motion. Next we will see the relative position. So position denotes by the letter S, okay. So what I said? So object A and object B we have taken. So position of the objects, if I want to calculate the relative position, no, this is the formula, like relative position, relative motion, relative velocity, whatever it is, simple thing. So if VAB, velocity of A with respect to B, see how I need to pronounce is velocity of A with respect to B, I will say, or else if I write like this, VBA, which is nothing but velocity of B with respect to A, okay. So if I want to find VAB, no, this is the formula, VAB is equals to VA, the first one is A minus VB, okay. Now this one VBA, which is nothing but VB minus VA, understood, that's the thing. So in position they have said SAB, like position of AB is equals to SA minus SB. If in this case no SBA, which is nothing but SB minus SA. So it helps in determining how far object A is from the object B with the given directions. One more thing, keep in mind, take a graph. We know that there is positive x-axis, negative x-axis, positive y-axis, negative y-axis. So object is going from this side, no, like in the right side it is positive, in the left side it is negative, in the upward positive, downward negative. Okay, keep in mind whenever you are solving the problems. So upward positive, downward negative, in right side, that is in x-axis positive, minus x-axis negative. Okay, no, useful in the tracking the problems. Okay, next thing, so relative velocity, as I said, velocity of AB is equals to velocity of A minus velocity of velocity of B. Okay, velocity of A with respect to B, right? Okay, so if moving in the same direction, like if object is moving in the same direction, no, A, this is moving like this, B, it's also moving like this. If it is moving in the same direction, I will consider like it's a subtract the speed, like VAB is equals to VA minus VB, or else no, what I said, this is positive, this is also positive, so positive minus of positive, so minus only. Suppose this is A and this is B, so A is in the positive direction, B is in the negative direction, no, keep as it is, VAB. As usual the formula is VA minus VB, but if I apply the symbol, no, like either positive or negative, okay, the sign convention, that is VA positive but VB is minus VB, like minus of minus VB, so VA plus VB. So same direction subtract, opposite direction add it, that's what we got, no. So by using the sign conventions we got it, either it's a subtraction or addition. So used in the understanding how fast two bodies approach or recede from each other, either approaching or going away from the bodies. Next thing, relative acceleration, similar to relative velocity formula only and position formula only. So acceleration of AB is nothing but acceleration of AB is equals to A with respect to B, A minus B. Okay, similarly acceleration of B with respect to A is nothing but acceleration of B minus acceleration of A. This is the acceleration of A as seen by B with respect to B, no, yeah. So helps in non-inertial frame and in relative motion of accelerating bodies. Okay, this is the formulas for acceleration. Next, velocity of approach and velocity of separation, that's what we have seen in the last before slide. So same direction in the sense, so B is going like this, A is going like following, so approaching, no, like A is approaching B. In this case, like, wait, I will show you here in the same slide. So object A is there, object B is there, so velocity of approach in the opposite direction, velocity of separation going away from, so this is positive, this is negative, this is negative and this is positive. Now velocity of A with respect to B, VA minus of minus VB, which is nothing but VA plus VB. Velocity of B with respect to A is velocity of B, that is negative V minus VB minus VA, right. Now for this one, velocity of A with respect to B minus VA, it's going in the negative direction, minus VB. Here velocity of B with respect to A, which is nothing but B is in the positive direction, VB, A is in the negative direction, minus of minus VA, so VB plus VA. So this is the conditions for approach and the separation. So this is for approach and this is for separation. Okay, take a note of this. Yeah, so real life applications. So two moving vehicle on roads, airplane and wind effect, boat and river currents, rain appearing slanted on the moving observer, like rain is coming like this. Yeah, we'll see the problems for this also, like a boat and river, rain and man, everything we'll see. Okay, okay, this is the first question. Question number 1. An object A is moving with 5 meter per second and B is moving with 20 meter per second in the same direction, that is positive axis they have given. So let me take the axis. This is the axis, this is the positive x axis, no, in the same direction they said. So A is moving with 5 meter per second, B is moving with 20 meter per second, B is moving with 20 meter per second. I need to find the velocity of B with respect to A and then find velocity of A with respect to B. What does it mean? Velocity of B with respect to A. What is the formula? VB minus VA. Okay, first apply the formula. First thing, apply the formula, then apply the sign. Okay, before applying the formula, don't apply the sign. Okay, next, if VB it's in positive direction, okay, write as it is 20. VA is also positive direction, minus 5. Like minus is there, it's plus 5, no? So minus into plus, it's minus only. So 15 meter per second for the first question. Can you give the answer for the second question? Yes, you can give in the comment boxes, guys. Okay, we'll do it now. So velocity of A with respect to B, right? So what does it mean? VA minus VB, VA minus VB. So what is the sign for A? It is positive, so plus 5, minus what is the like sign for B? It is positive, so plus 20. So plus into minus 20, so minus 20 I have written. So 5 minus 20 is minus 15 meter per second. So when I see here, velocity of B with respect to A is 15 meter per second, but velocity of A with respect to B is minus 15 meter per second. Like speed is same, but the sign is different. Okay, it's positive and it is negative. Next we'll go for the second question. Question number 2. So two objects A and B are moving towards each other with velocities 10 meter per second and 12 meter per second respectively, as shown in the given figure. Find the velocity of A with respect to B as well as B with respect to A. Okay, so in previous case, no, like both are moving in the same direction. Okay, but in this case both are moving in the opposite direction. Okay, one is approaching another. So let me write it. First thing, sign, I will do it. So A is going in this way, so positive, no? B is going in this way, so negative. Okay, keep in mind. Next, first question, so first part of the question, find the velocity of A with respect to B, no? Velocity of A with respect to B is nothing but VA minus VB, right? What is the velocity of A is given? Yeah, 10 meter per second, B is 12 meter per second. So sign for A is positive, so plus 12 minus of velocity of B is 12, sign convention, that is minus, no, for B, minus. So minus 12, no, okay. This is 10 plus 10 and this is minus of minus 12. So it is 10 plus 12, nothing but 22 meter per second. Okay, we will go for the second part of the question. What they are saying? find the velocity of B with respect to A. Velocity of B with respect to A, which is nothing but VB minus VA, right? VB minus VA. So now sign convention. B is negative minus VB plus minus A is positive, so plus VA. So velocity of B is 12, A is 10, right? Minus 12 minus 10, which is nothing but minus 22 meter per second. So this is the answer for the second question. Part 1 22 meter per second and part 2 is minus 22 meter per second. So according to the observer, like reference point, the velocities signs changes, right? Okay, we'll go for the next question. Okay, so A and B are thrown vertically upward with velocity. So okay, body A is there and body B is there, an object. So I have thrown upward with velocity 5 meter per second and 10 meter per second respectively. Okay, G is given as G is equals to 10 meter per second square. Find the separation between them after 1 second. Okay, how we can find this one? Can you give an answer for this? Easy, no? Like both are thrown upward only, positive, positive. See, easy, right? So acceleration opposite, that is negative, right? Negative. So minus 10 will take, right? Simple thing, guys. G is acting like this, 10 meter per second square. What we have seen in the graph, plus plus minus minus, downward minus, upward plus plus. Okay, now the distance I need to find. So SA is equals to UT plus S is equals to UT plus of AT square, AT square. So SA, position A is equals to U. What is the velocity of A? It is 5. After 1 second they have said, no, 1 second. So into 1 plus of into minus 10, no, minus 10 into 1 square. So G, like A is considered as G, no, considered as G. So 5 minus, this is 5, right? So minus 5, which is nothing but 0, which is nothing but 0, right? Yeah. So 5 minus 5. So SB is equals to position B. This is 10 meter per second. Okay, 10, 1 plus of into minus 10 into 1 square, 1 square. So what is the answer? 10 minus 5, which is nothing but 5, right? What they have given, like what they asked, they find the separation between them after 1 second. So separation between them is 5 meter. See, SB and SA. So SB minus SA, the separation is 5 meter. Okay, if I want to write SA to SB, no, it is minus 5, but we'll see what is the value, like only the separation magnitude we will see, no, like it is 5 meter. Got it? Yeah. So next we will see relative motion in 2 dimension. So as of now we have seen only about the 1 dimension relative motion. Now we are going to see the 2 dimension. So 2 dimension in the sense, what we will do, if like object is thrown in XY plane, we will take the components in X axis as well as Y axis, right? That's what. So relative motion in 2D, relative motion in two dimension, consider the motion of an object in a plane. So XY plane, okay, object is thrown like this. So we will take a component in this case, either like both X axis and Y axis. It requires the use of vector subtraction to compute the relative velocity. Okay, but we are going to use the same formula only. VAB is equals to VA minus VB, or VBA is equals to VB minus VA. This includes both x axis and y axis, like x component and y components of the velocity, right? So while doing problem we will able to understand. So breaking velocities into components. Okay, first thing, velocity of the A, like two objects. Now we are considering two objects. So one object is thrown like this, velocity of A, another object we have thrown like this, velocity of B. Okay, now I need to take the components of both, like I need to take component for A as well as B. When I take the component of A, no, VA with respect to x axis, VA with respect to y axis, right? Next, VB with respect to x axis, VB with respect to y axis. Then velocity of A with respect to B. So velocity of A with respect to B. What we know? Velocity of A minus velocity of B. Now I need to subtract it. So x axis minus x axis, no, like VAX minus VBX. This is one, comma, velocity of AY minus velocity of BY. That's it. So if we want to find the final answer, no, velocity, that resultant will be under root of this square, like velocity of AX minus velocity of VBX the whole square, okay, plus velocity of VAY minus velocity of VBY the whole square. We will get the velocity of A with respect to B. Okay, this is the final thing. Okay, no need to worry when they give in the two dimension. Take component in x axis, y axis, then apply the formula V minus, like velocity of A with respect to B, that is VA minus VB, like same formula as we used in the one dimension. So subtract x axis, A minus B, like A x axis, B x axis, next y axis, A y axis, B y axis, then take the root over that, like you will get the final answer, velocity of A with respect to B. So direction of relative velocity, like first if we want to find the angle, no, if I want to find the angle, this is opposite, this is adjacent, no, opposite, this is adjacent. So tan theta I can use, no, tan theta is equals to opposite by adjacent. See guys, no need to worry, whatever you have learned in the vectors only we are going to use in the motion, that like relative motion in two dimension. Okay, this gives the angle of V, velocity of A with respect to B in the x axis, respect to x axis we will take. Okay, that's what we have taken here. Tan theta is equals to opposite by adjacent, which is nothing but that is y axis by x axis. Whatever we have written here, that is VAY minus VBY divided by VAX minus VBX. That one I should write it here. Okay, VAY minus VBY divided by VAX minus VBX. Now the question given, a car moves, so car A moves east at 60 km per hour. So east direction, this is the east direction, right? Am I correct? So this is the east direction. Car A moves with 60 km per hour. Car B moves north. So this is north. So I will write it here. North, this is south, east, and this is west. Right? Okay. Find the velocity of A with respect to B. This is 80 km per hour. That is B. Okay. If I see in x axis 60 is there, what about y? 0, comma 0. Here if I want to write, it is 0, comma 80 B. Okay. Now you got both for x axis, y axis, like x axis, y axis, x axis and y axis. Okay. Now what is the formula, like A with respect to B, they asked VA minus VB. So VAX minus VBX, one thing. Next VBY minus, this is VAY minus VBY. Am I correct? Yeah. So AX is 60, b is 0, comma. Now this one I'll write plus itself here, and I'll take the under root of that. Okay, finally. So here 0 no for a, y minus 80. So I can say that 60 I cap, it's in the positive direction, no, x axis, 60 I cap minus 80 j cap. Am I correct? This is the velocity with respect to a, with respect to b for a. Now I need to find the final answer. No, under root of 60 square plus minus 80 square. 60 square is 3600. Am I correct? Yeah. Plus 80 square is 6400. I'll get 10,000, right? The final answer is 100 kilometer per hour. Velocity of A with respect to B. Okay. We'll go for next question. Okay. Once we'll see the application and go for the next question. So application similar only, guys. Airplane navigation with wind effect, boat crossing river with current, rain and man problem, collision detection. Okay. So understanding components helps in solving this problem efficiently. So don't forget to skip the vector classes. Okay. This is the next question. I'll zoom it. Okay, now it's visible, I guess. An old man and a boy are walking towards each other and a bird is flying over them as shown in the figure. Okay, so a bird is flying in xy plane. They have taken the components also, like 37 degree it's flying with respect to x axis. So we know that sine 37 and cos 37, how to find it, right? So draw a triangle like this. This is 53, 90 and this is 37. So largest number 5 in hypotenuse, another number 3 and then remaining number is 4. So I can find sine 37, cos 37 by using the 3, 4, 5 triangle. Okay. Then like 3 is there. What is the velocity of 3? It is 0. Boy is running with 16 meter per second in positive x axis. An old person is walking with 2 meter per second in negative x axis. Okay. Now the question is find the velocity of tree, bird and old man as seen by a boy. Like velocity with respect to boy, like velocity of boy with respect to tree, bird, old man. Okay, that's what the question says. Can I give answer for the first question, guys? You can comment the answer for the first question, second question and third question. We will say in the next class. Okay, we will meet in the next class, day 4. Okay guys, thank you.